So are we good to get started? Perfect. Okay. Well, my name is Adam Moser. I'm the arborist market manager for Yale Cordage. I'm very fortunate to have been in this role with Yale for coming up on 10 years almost, and have learned a lot in my time spent dealing with all the challenges of the tree care industry. So, really looking forward to talking to everyone about our products here a little bit and kind of providing a general uh, sort of guidance and recommendations for uh, ropes for arborist applications. So there are a few things that we really encourage people to focus on when they're talking about selecting ropes for tree work. There's kind of a triage of items that are maybe at odds with one another when making a product selection, whether this be for a climbing line or a rigging line. But I've laid them out here, and we're going to talk about each in more detail in this presentation. So from my perspective and my opinion, the most important aspect when considering a rope, regardless of the application in tree work, is actually going to be the durability of the product. As everyone who's watching this webinar is going to know, tree work is a pretty abusive and harsh work environment for any equipment that's put out into the field. And the ropes are definitely subjected to quite a lot of wear. So the durability of your rigging lines and your climbing lines is going to primarily be determined by the construction. It can be heavily influenced by the fiber type, so that's the actual composition of the ropes themselves, but really it comes down to the construction. Just a few general things. Polyester is more durable than nylon in most applications. Something like an HMPE, that would be your Dyneema or Spectra fibers, is going to have a very low melt temperature, especially compared to nylon or polyester. We're going to talk about that in more detail here in a moment. And then your tech cords like Aramids, Kevlars, and Technora, they really don't melt at all, but they have a very high coefficient of friction, which can cause other issues in the context of durability. The next most important, I guess, attribute of the rope here is going to be the strength itself. So unlike durability, which is really heavily influenced by construction, the strength is going to be primarily determined by the fiber type. So that's the yarn that actually makes up the rope. We will often sacrifice a little bit of strength in order to achieve an acceptable degree of durability. I'll show what I mean by that when we look at rope construction in a moment, but strength and durability are somewhat at odds with one another. High modulus fiber rope types have a much higher tensile strength than high tenacity fibers. So again, those would be your Dyneema type products in comparison to polyester and nylon. But they come with oftentimes an order of magnitude increase in price. So the strength can sometimes become pretty expensive. In my experience, I encounter a lot of people in this market that are shopping, especially in rigging lines, on the sort of merits of strength alone. You know, they call in and they say, what's the strongest rigging line you have? And of course, we could go back and say, here's a 2.5-inch double braid, but that's certainly not going to be suitable for most applications. So there are other factors to consider. And then finally, something that I think is often overlooked in this market is actually the dynamic performance. And really what I mean here is the stretch of the rope, or the ability of the rope to absorb energy in a dynamic fashion. So that's going to be, again, determined by the fiber type. It can be tweaked a little bit by the construction of the rope, but certainly the type of material that the rope is made out of is the biggest factor. So high modulus fiber ropes like Dyneema, while they're very strong, they obviously have very low elongation and very poor dynamic performance, especially when compared to high tenacity fibers, polyester, and then the highest energy absorbing capability or the most dynamic rope being nylons. So I mentioned that the strength and durability are somewhat at odds with one another. And this is a little bit of an attempt to try to visualize how the rope construction can influence the durability and strength. So when we refer to braid angle, I'm talking about essentially the red triangles here on the bottom of each of the 3 rope images, and how steep an angle that hypotenuse of the triangle, I suppose, makes with the axis of the rope. So from left to right, we have our Ultrex winch lines, which is 100% Dyneema material, and we're obviously trying to maximize the strength of that fiber since it is quite expensive. And you'll see that it's quite a steep angle there. It actually results in a more loosely braided construction. As we go further to the right, we see our PE12, which is a general commodity sort of utility rope. That's braided a little bit more tightly. And then finally, we have our Optimus, which is our green sling rigging line for making adjustable slings and ultra slings, things like that. That product is not only the most tightly braided here, but it also has a strand construction change that we'll talk about in a moment. So low braid angle ropes, for instance, the yellow Ultrix here, are going to have a higher breaking strength than more tightly braided ropes. So that's a bit of the compromise. We're maximizing the strength of that fiber by braiding it more loosely. The problem with these loose braids is that they're very prone to abrasion and they're prone to snagging. So we would say that the Ultrix product, while it is stronger, may be more susceptible to wear and tear, and as a result, may be less durable. We can make a more tightly braided rope in order to increase the durability. A good example of that is going to be just about any climbing line, but it does sacrifice some strength. Finally, the big difference between the orange and green rope that's shown on screen here is actually the ply of the construction. So the orange rope is what we call a single ply construction, meaning that there's only one strand per carrier or per bobbin on the braider. So there are only 12 individual strands there. And then the green product, our Optimus, is a 2-ply construction. The biggest trade-off here is that the 1-ply product can be slightly stronger, but they oftentimes are more difficult to splice. And then a 2-ply construction, which may be just a little bit weaker, is going to be much more readily spliceable. And that's going to be really important if you're fabricating something like an ultra sling, where you're going to be performing a lot of intricate splicing in the rope itself. We encounter a lot of questions also relating to Kernmantles and asking if we make Kernmantle ropes. And there's a little bit of a misnomer that seems to be pretty common in this industry, where people talk about Kernmantles. From a definitional standpoint, Kernmantle simply means that there are independent core and sleeve components of the rope. So there's an outer jacket or sleeve, and there's some sort of interior load-bearing core. So technically, both a double braid product and a parallel core Kernmantle, they are both Kernmantle products. But I think oftentimes people associate Kernmantles with being specifically parallel core ropes and not having a braided core. The biggest advantage of double braids is that they're going to be much easier to splice. They're going to handle knots better. They're going to be easier to tie knots and hold knots than a much stiffer Kernmantle. And they're going to bend. They're going to be just a much more compliant product, meaning it may pack smaller into a rope bag or something like that. Some of the advantages of a parallel core rope is that they can be stronger in some applications. They may have lower elongation, especially when you're talking about climbing lines. And they're going to be really firm, less prone to flattening. So that's can be a bit of a subjective issue. It doesn't actually hurt the rope at all if it flattens a little bit in your systems. But some people prefer a rope that stays really round depending on what they're using it for. Currently, Yale doesn't actually make any parallel core Kernmantle constructions. Pretty much everything we make that has separate core and sleeve components is going to be a double braid. So the materials, the composition of the rope are the things that are going to primarily determine the strength of the rope, as well as its elongation. This gets pretty technical, and I'll go through it relatively quickly here, but when we talk about high tenacity fibers, we're talking about the conventional commodity type materials that are in the market, the polyester, nylon, and polypropylenes. When we talk about high modulus fibers, these are going to be things like Spectra and Dyneema, aramids like Technora Kevlar, and then LCP, which is Vectran, which is pretty much right in the middle of an HMPE and an aramid in terms of its performance. When we talk about high tenacity fibers, polyester is going to be the most common one that you come across. Nearly universally in arborist ropes or ropes for arborist applications, whether they be rigging lines or climbing lines, we're going to be talking about things that have a polyester sleeve on them, and then they may have a different composition for the core. And the reason for that is polyester yields very good abrasion resistance, and it's relatively inexpensive compared to the other fibers here. Polyester also has the ability to absorb some energy in a dynamic context. It can handle a little bit of shock loading and dynamic loading, whereas things like Dyneema are not going to be suitable for that application. The polyester ropes are going to have much lower elongation than nylon. Nylon can have up to twice the elongation as polyester, which there are advantages and disadvantages to each. And some examples of polyester ropes, which we'll look at in a little bit more detail in a moment here, are our XTC 16 climbing lines, which are 100% polyester. Our double braid Blue Moon climbing line, which is XTC 24, is also 100% polyester. And our Kernmaster Phantom, which is our SRS specific version of Kernmaster, which again is 100% polyester. Nylon, like I said earlier, can be a little bit less durable than polyester. It's a little bit more prone to wear and abrasion, especially if it's allowed to get wet and then dry again and doesn't have special surface treatments on it. As a result, nylon is typically going to be used in the interior of the climbing line or the rigging line where it's protected by a jacket or a cover of some sort. Nylon is still comparatively low cost, but it's not going to be as cheap as polyester. Some of the very high grades of nylon can be twice as much money as polyester, but it is going to yield us the highest possible energy absorption in that dynamic loading context. From Yale, nylon is going to be found in almost all of our CE rated climbing lines, especially the double braid climbing lines like our calamine. And just some examples of nylon ropes, the XTC 24, which in that case is going to be the calamine 11.7 product, the original Kernmaster configuration. And then also when we talk about our rigging lines, our Polydyne rigging line has a polyester jacket and a nylon core. Polypropylene is the least expensive fiber type. We don't really use very much of it in the ropes in this market. And a big reason for that is it can have some undesirable characteristics. It's very prone to UV exposure. It really has to be protected either with a coating or with a cover of some sort. But we do use it in some cases to add bulk to the rope. So if we want to make a rope a little bit larger, for instance, bump something up from a 9/16 size to 5/8 without adding a lot of cost, then we can put a little bit of polypropylene in it to get there. But it really doesn't contribute very much to strength. When we talk about our high modulus fibers, we're mostly talking about HMPE or UHMPE, which is the ultra high molecular weight polyethylene. These again would be your Dyneema or Spectra type products, all the SK 75, 78 type products from DSM. These are going to have, for the most part, the highest strength that you're going to be able to achieve, certainly per unit weight. So strength to weight ratio, when you're looking at these types of products, is going to be very high. They're going to have extremely low elongation, which makes them really well suited to applications like a winch line, but they're really poorly suited for use in like a negative rigging type application where they could be subjected to shock load. I mentioned earlier that these materials have very low melt temperatures, so we're going to talk about that more, but you start to see strength reduction in products made out of Dyneema or Spectra at temperatures as low as 120 degrees Fahrenheit, which is certainly a achievable temperature out in the real world in use. So some examples of our HMPE ropes are Ultrex, which we looked at earlier, Ultrex Plus, which is simply an Ultrex core with a polyester jacket on it, and then MaxiBraid and MaxiBraid Plus, which are slightly less popular options now. The next one here is our Aramids. These are going to be Kevlar and Technora. They're not going to be as strong as an HMPE. They are also going to be a little bit heavier, so the specific strength is lower. They have very good abrasion and cut resistance from external abrasion, but they have a very high coefficient of friction, so they can be prone to internal abrasion, actually wearing on themselves. The main benefit of an aramid fiber is that they don't melt at any temperature. So if you were to actually put a torch to one of these, you would see that unlike all the other materials on here, they don't melt, but they will thermally decompose. Essentially, they just burn at about 500 degrees Celsius. Because of that high temperature tolerance, they're really well suited for use in hitch cords, which obviously can generate quite a lot of heat. So our B-line hitch cord covers are made with Technora specifically, And our ring rope, which is our tech lanyard material, is also, the cover of that is 100% Technora. It does have a polyester core though. The last one that's listed here, Vectran, is a unique product. It's right in the middle of the HMP and aramids in terms of its performance. It can be, in some applications, the most expensive fiber that we're looking at, but it kind of splits the difference between HMP and aramids in just about every context. The biggest benefit is that it still has a very high strength retention at elevated temperatures, similar to the aramid. And an example of an LCP rope is going to be our B-lines, which have Vectran used in their cores. So we talked a bit about heat, and there are quite a few heat sources in tree work that we need to be mindful of. The most important thing to keep in mind is that all of our climbing and rigging systems are going to generate heat, specifically on lowering or descent. Any weight that is at some elevation above the ground has an intrinsic potential energy associated with it that needs to be dissipated as heat in order to yield a controlled descent. And even if it was an uncontrolled descent where you're not rigging things out at all and just dropping it to the ground, we're still dissipating that potential energy as heat. It's just the heat is into the earth instead of into your rigging system. So our rigging components like porter wraps, pulleys, rigging rings, are all going to generate heat. And metallic hardware in particular also stores quite a lot of heat, which is something we need to be mindful of. As a result of that, low melting point materials like HMPE should never be used in situations where you can achieve elevated temperatures due to friction. And also they have a very low coefficient of friction, so they really wouldn't be well suited for use on a porter wrap, for instance. You'd have a very hard time actually controlling the load on an HMPE rope around a porter wrap because of how slippery it is. Obviously, we have two kind of typical photos here of the most familiar heat sources that everyone's going to be aware of, but your hitch cords in your climbing system on the left, and then of course a porter wrap in a lowering system on the right. Suited for block rigging. Overall, they're going to yield better rigging performance. So they're going to be stronger. They're going to be better suited for either static rigging in the case of a polyester rigging line, where you want to have really good load handling in a sort of non-dynamic situation, or in the case of a negative rigging application, you could use something like polydyne and actually be able to absorb quite a lot of energy just in the elongation of the rope itself. Yeah, the biggest benefit when running double braid rigging lines through your block rigging systems is that they're going to be smoother and more predictable through these devices. The 12-strand ropes are going to be more bumpy. They may not run as smoothly through blocks or around porter wraps and things like that, and maybe a little bit less predictable. So regardless of whether or not you're looking at some sort of a controlled static rigging system or a dynamic rigging system, you're going to be talking about dissipating the same amount of energy in the form of heat. So if you have the same amount of mass, 30 feet off of the ground, you're trying to bring it down to the ground in a controlled manner, you're dissipating the same amount of energy. The difference is where that energy is actually being absorbed and handled by the system. The impact force in a high elongation material like polydyne, which has that nylon core, is going to be significantly less than the impact forces generated in a low elongation material like Portland braid or double esterlon. And the reason for that is that the energy, instead of relying on the friction in your porter wrap or in your rigging rings to lower the piece, is actually going to be handled in the elongation of the rope itself. So if you could, this is something I've always wanted to do, but if you could take a thermal imaging camera and actually look at a rigging system and see where the hot spots are, in a negative rigging application with a high elongation material, you would actually see that the rope itself would heat uniformly, regardless of whether or not it was subjected to friction through the rigging points. Static rigging applications are going to be a lot easier to control when using low elongation materials. So again, our Portland braid or our double esterlon, you're not going to have to worry about the stretch or taking up stretch in these systems before you can move a piece around, for instance. We're going to talk a little bit in more detail about some of our climbing lines, and I'll point out the products that are available from TreeStuff in particular, and it goes through the progression of climbing lines from some of the older products to some of the newer items that we have available today. But our 16-strand climbing lines have been Yale's bread and butter for a really long time. And in fact, XTC Fire, which is shown in the middle here, was our single most popular rope in any market for over a decade until very recently. It was surpassed by Blue Moon. So the 16 carrier product, this particular design was actually intended for the arborist application from the onset. It was designed and developed and tested as an arborist climbing line. The 16-strand construction makes it extremely durable. It's very tightly braided, and the individual strands are pretty large in the cover of this rope. I would not consider XTC 16 to be a Kernmantle, and the reason is that even though it has a core, the core is not load-bearing. The core is present on the interior of the rope to keep it round and to make it spliceable and provide a little bit of dynamic capability, the ability to handle a fall arrest type application. Yeah, the pretty tightly braided cover that's given here does allow the rope to be spliced, but it also has to be able to handle enough of a dynamic impact to pass our CE EN 1891 type A conformance, which is a 100 kilogram mass being dropped 2 meters, which is a pretty aggressive use case for these ropes. They can be hand spliced and they can also be stitched if necessary. And I would actually say that these are going to be the most durable climbing lines that we produce. Moving on to the next evolution in our climbing line options, we get into our double braid products. And I'm sure most people that are listening to this call are already familiar with our 11.7 options. The top product, as I mentioned before, Blue Moon, is nowadays actually our most popular climbing line. And then our 11.7 millimeter XTC Calamine, which is based off of the same construction, has a nylon core for a CE certification. The biggest benefit of getting into a 24 carrier double braid is that it makes the rope smoother than a 16 strand at the expense of some durability. The double braid construction is much better for running through false crotches or mechanical devices, zigzags, rope runners, spider jacks, anything like that. Either one of these can be easily spliced as a conventional double braid. The splicing procedure for these items is almost exactly the same as it would be for even an industrial rigging line, though it can be more difficult to extract and bury the core because of the tight cover. As you go up in strand count from a 16 strand to a 24 strand climbing line, the strands in the cover of the rope have to get smaller. And so you do compromise a little bit of durability. So when we get into these types of products, we start to recommend the use of friction savers or false crotches in the tree, cambium savers to protect the rope. The biggest difference between Blue Moon and Calamine is going to be the nylon core that's present in Calamine. Blue Moon is a bit of a better all-round climbing line. It can be run in a moving rope system or in a stationary rope system, provided that we're appropriately monitoring and taking care of friction, especially at the tie-in. The Calamine is really going to be better suited for moving rope systems. That little bit of elongation is going to make Calamine a little bit less pleasant to climb on as a stationary rope climbing line. A lot of our competitors actually produce a 32 strand climbing line. Yale doesn't currently make a 32 strand. We actually skip that and go right to a 48, which is pretty unique in this market. I'm not sure of other manufacturers that have 48 strand climbing lines, so it's something that we're quite proud of. We have two of our more recent 48 strand climbing lines shown here. So our Kernmaster Phantom, which has the same cover construction as our old Kernmaster, which is still available from TreeStuff, which would be our Kernmaster Explorer. But Kernmaster Phantom is a dedicated SRS climbing line with an all polyester construction and a red polyester core. Below it, we have our 11.7 XTC48 Scandier. Scandier was our attempt to basically improve the durability of the original Kernmaster design. So in the same way, the 24 strand is a bit less durable than a 16 strand rope. You do, again, compromise some durability when you go to the very small strands here on a 48 strand climbing line. The trade-off is that you have something that results in a very smooth jacket that's going to run very well in mechanical devices or in a hitch-based climbing system like a rope wrench. But they're not going to be as durable because of how thin that cover is. As a result, with Kernmaster in particular, we really don't recommend using Kernmaster for a moving rope climbing system. Scandier, on the other hand, can be run in either system as a moving rope system or a stationary rope system because we've essentially braided that jacket even more tightly to avoid things snagging and picking at the strands. In either one of these applications, we would still recommend using some sort of a friction or cambium saver in the tree to protect the rope, since again, they're not going to be quite as durable as our 24 strand or 16 strand options. And the last one to talk about, which is a bit of a unique product, are going to be our tech ropes. So these are going to be primarily some sort of an aramid jacketed double braid or Kernmantle construction. Our tech Kern, which really doesn't ever get used in this market because of the cost of it, is a 100% aramid Kevlar access line. And I believe in the 11 millimeter, it has a breaking strength of about 20,000 pounds, which is completely ridiculous. But a more reasonable option is going to be our 11.5 millimeter ring rope. So ring rope was developed specifically as a cut and heat resistant lanyard material. It's also used in some rescue applications and high angle rescue or fire rescue applications where they're worried about edge protection, cut resistance, and things like that. Both of these products are going to be able to handle elevated temperatures very well. But ring rope has a little bit of a party trick where if the cover is damaged, it immediately exposes a red inspection layer underneath the jacket, making it very easy to tell if the rope's been compromised and needs to be removed from service. Both of these ropes are going to have extremely low elongation, less than 3% at break, which means that they're really not going to be suitable for any type of dynamic or fall arrest application. But it does make them very efficient for ascent. So hopefully everyone on this has learned something. I have my contact information up on screen. I always encourage people to reach out to us directly if they have questions related to our products. I tend to field a lot of end user questions related to appropriate rope selection and for various arborist applications. So I really do encourage folks to reach out to me if there's something that I've missed or if they would like some additional information about anything that I've discussed.
I actually have a quick question here for you. This is from someone on YouTube. Why do I get lots of twists in my Yale XTC line when I'm using a prusik?
So that is one of the issues that, depending on which prusik is being tied, it can impart a twist in the actual ascent line. And I've experimented with this quite a bit. The ropes themselves are intrinsically balanced. They don't have any twist built into them. But some hitch cords do have a tendency to impart twist in the rope, especially on descent. I found that distal hitches work pretty well in preventing that, but I will admit that I'm not the best resource when it comes to a range of different hitch cords that are available or that can be tied for an SRS climbing system. So I would recommend just trying different hitch configurations and seeing what works well. And you may find something that is less prone to inducing twists in your climbing line with a little bit of experimentation.
Okay, great. I don't think I have any other questions here right now. I just want to show people real quick where you can go on TreeStuff to find all of Yale Cordage stuff, items. So if you go anywhere where there's rope, you'll find Yale ropes. And if you want to look at what each are like just the Yale ropes, all you have to do is click on the brand there, Yale Cordage, and it'll take you to this page. Or you can type in up at the top Yale-Cordage, and you'll get all of their awesome items here. So thank you very much, Adam, for doing this for us. And we hope to have you back again and talk a little bit more.
Absolutely. Thank you very much, Kel.
Okay.
It's my pleasure.